Hello everyone, welcome to Code Guide. And today in this session, we'll discuss the topic AutoModels and its implementation. So let's start. Now, first step would be how to load models. So how to load models. Now in AutoModels, we have, or for the models, they have two types. First one is the AutoModel, which is the PyDot model. And next is the TensorFlow AutoModel, which is the TensorFlow model. First of all, we'll see the AutoModel from transformer import auto model. Okay. Suppose first of all we'll define the tokenizer. So auto model, auto tokenizer, auto tokenizer from retrain, and I'll mention the model name. Distillbird, Distillbird, base, and Ankit. Mention the model. Now suppose I pass any input to a tokenizer is equal to tokenizer, and I'll pass my input. This is a good painting. Okay. Tokenizer. Okay. Now I'll pass the model. Model is equal to auto model. Auto model, and when I pass from retrain, I'll mention the model name with the model. And when I pass the input to the model, what happens will be, so we got an error here. Now when I pass input tokenizer and suppose this painting is good, so this is a good painting, and I will say return tensor equal to pt, that is the PyTorch, and then I will pass the input. So we'll see what happens. So we got the output, but this output is not in human readable format. We got this is in that is the logit. So for that we need to give another head which is not available for the auto model. Now after this we can save this model also. So when we say model dot save retrain, and I will mention it as BERT model. So we got a model saved. That is the BERT model. Now we can also load this model here. So that we'll use save model equal to auto model from retrain, and I'll just mention the path. Okay, and I will load it. Now we'll build a pipeline here. First of all, pipeline. So from transformer import pipeline, and suppose I want for sentiment. So just I'll mention pipeline, and I'll mention the task. That is the sentiment, and this is my task. Okay, and I'll mention sentiment. This is a good painting. Okay. So as they have not mentioned any model name, so it has been using a digital bot. based on case fine tune this model. We will copy this and I'll mention it as model. After running the cell, we got that the label is positive as we have mentioned. This is a good printing, so good exactly denote positive statement. So we got the label as positive statement. Now we'll load tokenizer for this model. So tokenizer from transformer import auto tokenizer, and I'll mention the tokenizer auto tokenizer from pre-train, and I'll mention the model. Okay. Now if I pass an input to my tokenizer, suppose this product is good, you'll see. You got input ID, start of the sequence, end of the sequence, attention mark, for which token attention should be calculated. Then you got the index number of the token from the vocab, that this is the index number 2023 in the vocab. So that is the tokenizer. So what I'll do, I'll pass multiple input. You have been for a single input. Now I'll pass the multiple input. So what I'll make, tokenizer, pass this product is good. Okay. Then I'll pass this is bad. Okay. I'll pass suppose not good, and last I'll pass it as matrix. Okay. Now after this, we have seen the parameters we can pass here is padding. So I'll mention padding equal to, so the part 2, and for return tensor equal to 6. Now when I check the input, we got as we mentioned padding is equal to 2, for it to do padding at according to the longest sequence, that is this product is good, according to this it will do padding. For the second sentence we will have one padding, which is 0. For the third sentence we will have two padded tokens, and for the last we have three padded tokens, including the start of the sequence and the end of the sequence. Mixi has the index number 18307 in the vocab. This is the attention mark. For pirate tokens will not calculate attention, or will not calculate attention for the pirate token. That is the input. Now we will see the model. We have seen the tokenizer. Now we'll see the model. So from transformer import auto model and I will need my model equal to model 1 equal to model from pre-train. I'll mention the model name, that is the model. Okay. Now when I pass my input to the model, we will see what we will get. Model 1 input. Okay. And I'll see output dot last event dot. So here we got shape as 4, 6, and 7, 68. Now here 4, it stands for number of sequences in batch. Number of sequences in batch. The 6 is 6 number denote number of tokens per sequence, right? Number of tokens per sequence, and 768 is the vector dimension of each token. Vector dimension of each token. So this is the last state. Now the head basically means the output layer, right? Head basically means the output layer. Now whenever we pass any raw text, raw text, we first of all convert it into numerical format using the tokenizer. So we have tokenizer. After that, raw text we pass to the tokenizer. Then there is a model, right? After auto tokenizer, there is a model. And after model, there is post processing, and then we get the prediction, right? then we get the prediction. This is the format. Now in this case, the model which we are using here, it has multiple input here for the model. For the model, what is the input here? First of all, we have model input, then we have embedding, then are the layer, that is the hidden layer, then there is the hidden state, then is the head, and then we get the model output. That is the logit, that is the probability. Right. Now this whole task from embedding towards the head, this whole can be done using a specific head. Okay. So this is the full model, and we can give different head by using functions like AutoModel for sequence classification. So this entire part will be covered by this kind of a head we are giving, that is full model for auto model for sequence classification. Now we'll see how to use it. First of all, we are using the auto model, right? Auto model. The auto model is basically a base model. It will it will provide provide us contextual embedding, provide us contextual embedding, and then we have auto model, auto model for, and these are the tasks. For whatever task we want, we can use that. For auto model for sequence classification, that is the model with particular particular head, that is the output layer. Now we'll see how to use it. So from transformer import auto model for sequence classification. We'll mention a variable named sequence model. We'll mention auto model model for sequence classification. Mention from pre-train, and I will mention the model name, that is the model. I'll mention the variable logit sequence model, and I'll pass the input. When I print this logit, you got the probability of the answer. Basically, here auto model is a base model, and output is in contextual vector. Output is in contextual vector, and auto model sequence classification is basically a base model plus classification head. Classification head, where output is logit. First of all, when we use the auto model previously, yeah, these are the contextual vectors where we got in the output previously. Yeah, when we use the model here, auto model, we got the contextual vector after passing the input to the auto model. But in case of the auto model for sequence classification, we gave the head, that is the classification head, and we got the logit here. It is base model plus classification. Now, if you want to convert the logit into a ID label, we will see that. We'll import first of all dot. Okay. Okay. Logit dot logit. Okay. Okay. Dot dot, mm, dot functional dot tokenize with mark logit logit. Okay. Animation equals model dot config. No, that is the 0 is for negative and 1 is for positive. So this is the use of auto model here. If I pass multiple input to my sentiment named model, so wait, before or this is bad, not bad, not bad. Yeah, good. So it shows label as positive for the first one and score is 0.99. For second, it is negative. For third, we should have used positive. It is showing positive because we are seeing here it is not bad. And fourth one is positive. Okay. I hope you guys understood the auto model part. We also have seen auto tokenizer, auto model, and now we can use our particular model for inference also uh, based on our task. And you guys can practice different examples for different tasks and get the output and see the inference how the model performs. And I will see you in the next session with the new topic. Till then, bye.